An enduring understanding is a concise and overarching concept or principle that encapsulates the fundamental insights and knowledge that students should gain from a course. In the context of a course like tissue biomechanics, establishing an enduring understanding can hold significant value for several reasons. Two will be highlighted here. First, enduring understandings provide clarity of focus. Tissue biomechanics is a complex field with multiple facets, including mechanical properties of different tissues, their responses to various forces, and their role in physiologic processes. Defining an EU focus on the key concept that truly matters prevents the course from being a mere compilation of facts. Second, enduring understanding sets a conceptual framework. An enduring understanding provides a framework that connects various topics and ideas within the course. It helps students organize their learning and understand how different concepts relate to one another, creating a coherent and structured understanding of the subject. Before we take a closer look, the painting Ambassadors illustrates a very complex situation. Go to the website I've noted. And while it may seem there are random items scattered about in the picture, once you understand the backstory, the painting is highly informative. So I hope the enduring understanding contributes similarly to your own journey. So what is an enduring understanding? The summary text fairly concisely describes EU. Enduring understandings are statements summarizing important ideas and core concepts that are central to a discipline and have lasting value beyond the classroom. They synthesize what students should understand, not just know or do, as a result of studying a particular content area. For this class, let's comment further for clarity. Sometimes it can be a challenge to identify a project that you believe meet course objectives and meet your needs for, say, an applied understanding of tissue biomechanics and decision making at work. One method for everyone is to consider how to craft your project in a way that could lead to an enduring understanding. I provided some sample statements for a few FATs of this course. Let's take a closer look with some examples. Let's take a look at the course design from a higher level. We see in this diagram that an EU is a pathway for linking the overall course topic to very specific essential questions that we may wish addressed throughout our studies. There are several advantages to this. First, crafting an EU often involves distilling concept ideas into a succinct statement. This challenges both instructors and students to think critically about the core concepts of tissue mechanics, encouraging higher order thinking skills rather than just rote memorization. Second, tissue biomechanics is inherently interdisciplinary, and an enduring understanding acts as a bridge between theoretical knowledge and practical concepts, guiding students in understanding how biomedical principles underpin both scientific understanding and technological advancements. Third, and maybe more important, motivation and engagement. An enduring understanding can be inspiring, providing students with a big picture perspective that showcases the significance of their learning. Understanding the overarching concept's real-world implications can foster motivation and engagement as well, as students grasp the meaningful contributions they can make in their chosen fields. In summary, establishing an enduring understanding for a course like tissue biomechanics imparts a sense of purpose, clarity, and depth to the learning experience. It aligns the course content with overarching principles, enabling students to develop a holistic and lasting comprehension of tissue biomechanics and its broader implications. Let's take a look at building out each thread in a bit more detail. Looking at course concepts like modeling and simulation, one of many possible questions could be, how can basic research inform advanced simulations? The question might seem simple, but if you are familiar with, say, advanced collagen research, and are also familiar with Stanford's OpenSim system, you basically have the challenge of integrating length and time scales. After study, research, and some translational effort, you eventually see a pattern that becomes an enduring understanding, and that is, contemporary simulation systems like OpenSim were designed to support customizable routines linking research results, enhancing capability. And this notion of simulation practice stays with you and frames strategic work. Yes, this is a simple example, but you get the idea. More fundamentally, an enduring understanding discussion links the enduring understanding to the stated learning objectives, and these are often found in a syllabus itemized in an isolated way. The EU framework provides the link between learning objectives and questions you hope to answer throughout the course. Let's look at one more example. In the context of non-invasive systems, this is a very broad topic, and as we indicated earlier, these systems could either involve imaging tools or the so-called field of wearables. Following the thread of wearables, we wonder what, despite the commercial success of wearables for general consumer use, usually recreational, can wearables provide any useful data for clinical and medical decision making? Again, after study and research that touches on the learning objectives shown, an enduring understanding might be that the lack of clinical trials for wearable device validation limits the utility of these devices for clinical decision support, though they are fine for recreational use. These two examples of a wide variety of EUs that could be created, and the purpose of the first assignment is for you to personalize the course by establishing an enduring understanding for you and the project you might pursue. If you have any difficulty navigating the enduring understanding garden, if you will, just text or email, and I'll work with you.